Now that you've thought about the people, the next thing I want you to think about is the mathematics, because it is all about the mathematics. So if I think back on my career, I started teaching in 1988, and it was clearly my job to show students how to do stuff. How do you add fractions? How do you solve equations? It was just all about doing. The transition, as I see it, if I could just capture it in one little simple statement, the emphasis now is on developing ways of thinking. And these ways of thinking lead to habits of thinking so that students will have effective, efficient, flexible, and fluent ways of doing. So the doing actually emerges from the thinking, reasoning, and problem solving that we do in mathematics. Now, the standards for mathematical practices that have been out there now for years were really exciting to me when I first saw them. When I heard about the Common Core standards, I thought, okay, here we go, another shift in education. Let me look into this thing. And right away I saw these standards for mathematical practices and I thought, oh, that's different. Because now we're going to expect students to make sense of problems and persevere in solving them. Persevere in solving them. Reasoning abstractly and quantitatively. The focus here I'd like you to take is on the word reason. Students will construct viable arguments and critique the reasoning of others. I want to emphasize that, at least in my career, especially as a student, I don't think I ever, as a student, had to construct a viable argument. I watched teachers construct viable arguments at the chalkboard all day long, but I don't think I ever really had to do that. So now we're expecting students to make sense, to reason, so that they can construct viable arguments and critique the reasoning of others. So now we have to imagine a classroom situation where students are sharing their viable arguments. Maybe it's in small group, maybe it's in front of the large group, but students are sharing perhaps at the dot cam or at the whiteboard, and the expectation is that there's going to be a critique. Now I want you to be clear that critique often has a negative connotation, but when I hear critique, I think of three things. A critique could be somebody presents and another student says, oh, that really made sense. And they would articulate clearly, specifically, what that is that made sense to them. Or maybe a student presents and the critique is in the form of, I didn't really understand what you said when you said this. Could you help me to understand it better? Or maybe a critique could be more in the traditional sense of the word, where there's a disagreement, where somebody says something and somebody challenges that in a professional, polite, respectful way. Modeling with mathematics, the idea here is the application, real-world applications of mathematics, where students are solving problems that are actually relevant to at least somebody's real life. Using appropriate tools. Mathematical tools could be manipulatives, but also could be, we use sometimes formulas, we use tables, we use graphs, we use images, diagrams to help us understand things. Attending to precision is the idea that as students are engaging in mathematical thinking, mathematical communication, that they're being very precise. They explain things, articulate things very deeply and well. Look for and make use of structure, the mathematical structure. So when we say, for example, we invert and multiply when we divide fractions. Well, if it's just done because that's just how you do it, then that's a problem. This standard for mathematical practice about structure is more about helping tie together the making sense, the reasoning, the viable arguments, so that there's this mathematical structure at play so that the algorithm, for example, for division of fractions, makes sense. And then finally, look for and express regularity and repeated reasoning. Notice the emphasis here is on repeated reasoning. I don't know about you, but when I was in school, they often would assign 1 through 75 the odds. And I think the issue there was not repeated reasoning, but repeated doing. I would just do the algorithms over and over and over again, but I really did not understand. And so now we're going to expect students to engage in repeated reasoning so that they could package together these ideas into efficient and fluent and flexible ways of doing. In addition to the standards for mathematical practices, the National Council of Teachers of Mathematics has, about 2 years ago now, released a document that has standards for math teaching practices. And those standards are these: establish mathematical goals to focus learning. Implement tasks that promote reasoning and problem solving. I hope you see a parallel between what we're expecting students to develop in terms of mathematical practices and what we're expecting teachers to do to help develop those mathematical practices. So implementing tasks that promote reasoning and problem solving, use and connect mathematical representations. So there is the more formal abstract symbols in mathematics, but there are graphs, there are tables, there's diagrams, and we should help students to connect them. Facilitate meaningful mathematical discourse. Imagine a classroom where students are talking to one another about mathematics as they make sense. Pose purposeful questions. Asking questions to either facilitate learning, to advance student thinking, to challenge student thinking. We need to be artful in our ability to ask purposeful questions. Build procedural fluency from conceptual understanding. I love this one. Procedural fluency is still part of mathematics, no matter what the sometimes negative people say about our current standards. Procedural fluency, basic facts are still a part of what we expect students to know and be able to do and understand. But where does procedural fluency come from? It comes from conceptual understanding. Support productive struggle in learning mathematics. I believe that if something is worth learning and worth learning well, that probably there's going to be a little struggle in learning that thing. But notice the word productive struggle, and that's our job as teachers to be on alert for when does a student's struggle cross the line from being productive to unproductive. And if it crosses to unproductive, what do we do about it? Do we come in and ask a purposeful question? Do we have them talk to us about what they know to move them ahead, to get back into this productive struggle? Elicit and use evidence of student thinking. Our teaching should be focused on our students' thinking, and we need to then respond to our students' thinking in terms of the direction and trajectory of our lessons. Now, sometimes when you think about all of these things, the mathematical practices, and the teaching practices, sometimes it feels like you might be riding a backwards bike. Will you please jump ahead to the forum site, and will you please watch this video about riding a backwards bike, and in connection to what you've just heard me talk about, and then reflect. Read through those standards for mathematical practices. Is there anything that gets you excited? Are there items that you're wondering about? And then the idea is that students who complete a K-12 math education and have developed the math practices will be prepared for college and career. Do you agree? Why or why not? I would like you to have a conversation and post your responses. But please first go back and watch the backwards bike. And then you can move on to the next segment. Thanks.